Hello and welcome everyone to an interesting video on the principle of mathematical induction. This might sound quite complicated as you can see written on the board here, but trust me, it is not. Mathematical induction is simply a technique or a method used in proving the correctness of mathematical statements for all positive integers. And as you can see right here, written on the board before me is a mathematical statement where you have the left part and the right part. So this statement says that 1 plus 4 plus 7 plus dot 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 plus 3n minus 2 is equal to n multiplied by 3n minus 1 all over 2. So we are going to try to prove this statement to show that this left-hand part is equal to the right-hand part. So that is the goal of the principle of mathematical induction. And there are three steps to proving statements using mathematical induction. The first one is the base case. It is called the base case. And for this base case, we are going to prove that n is true for the smallest possible value. Usually n is equal to 1. As you can see from here, we have a 1. So you're going to start from 1. You're going to test for n is equal to 1. If after testing for n is equal to 1 and it is true, then you can continue with the proof. But if it is not true, then there is no point of continuing because you can never get the correct proof for this very statement. Okay, and what do we mean by testing for n is equal to 1? It simply means that wherever we see n, we substitute a 1. So we put a 1 for n. For example, let's say I want to test for n is equal to 1. I'll simply put 1 here. It's now going to be 3 multiplied by 1 minus 2. That will give us 3 times 1 is a 3. 3 minus 2 will give us a 1. So if we get a 1 on the left hand part, remember that we're not going to work with this part. So we're going to start with this part that has an n. For this part, there is no n. So we only work with the part that has an n. For this part is going to be a 1. Now we're also going to substitute 1 for n on the right part. If we get a 1 on the left and get a 1 on the right, it means that n is equal to 1, or the base case is actually true. For the second step, which is called the inductive hypothesis, we simply assume true for some arbitrary positive integer k. So all we do at the second step is to set n equal to k. It is called the assumption step, where we assume. This might look quite complicated, but when I start solving this problem, you see it is pretty easy and simple to understand. And for the last step, it is called the inductive step, where we prove true for k plus 1. And for the last step, we're simply going to set n equal to k plus 1, which means that if it is true, if it is actually true for n is equal to k, then it should be true for n equal to k plus 1. So these are the steps to proving statements using the principle of mathematical induction. And when you're done with the proof, if it is true, we can go ahead and conclude that it is true by the principle of mathematical induction to get your full marks during assessment. So let's go ahead and solve this interesting question before us and see how it works. Remember that we are going to start from the base case and go to the inductive hypothesis, and from there we go to the inductive step where we prove true for n equals k plus 1. Trust me, it's not really difficult, but it's a simple method of proving mathematical statements. So let's go ahead and solve this interesting question. So I'm going to start from step 1. when n equals 1. So I'm not going to work with this part, but we're going to copy down this very part. This part that has an n, we are not working with this part. So I'm going to start from here. We have 3 multiplied by 1 minus 2. This is equal to, I'm going to bring down the right part. Hence, we're going to have 1 multiplied by 3. So wherever we see an n, we simply put 1 for n. Minus, let me use a square bracket in this case because there is a bracket inside already. Minus 1 all over 2. Let me simplify the left part. So 3 multiplied by 1 gives us a 3 minus 2. This is equal to 1. So for the left hand side, we're getting a 1. Let's simplify the right hand part. Starting from the bracket, we have 3 multiplied by 1 will give us a 3. Hence, we're having 3 minus 1 all over 2. 1 multiplied by 3 or 1 multiplied by anything gives us the same value. Hence, we're going to have 3 minus 1 is a 2. 2 over 2. This is equal to 1. Hence, we can say that, therefore, this holds true for n equals 1. We can see that on our left hand side, we've gotten a 1, and on the right part, we've also gotten a 1. Hence, this is true, and we can proceed from here. Let's assume we get a 1 here and a 3 here. We cannot proceed, right? So for the first step, which is the base case, the left-hand side and the right-hand side must be the same. If they're not the same, then there is a problem either with your calculation or that the mathematical statement is wrong. Unless you're asked to prove for equalities, then it's a different case altogether. But for this type of mathematical statement where you prove that the left part is equal to the right, you have to start from n equal to 1. And if you get both values on same sides or on both sides rather of the equation, it means that the statement is true for n equals 1. So let's go ahead and do the second step where n is equal to k. For step 2, I'm going to assume true for n equals k. So for the second step, you are going to assume true for n equals k. This is called the inductive hypothesis, where you make an assumption that n is equal to k. This assumption might be true or not, but it is just an assumption. So it is while proving for the last part that we will know whether our assumption was true or not. Okay, let's go ahead and assume true for n is equal to k. So what's going to happen is that we're going to repeat this again and then substitute a k for n. Since k is equal to n and n is equal to k, wherever we see n, we put a k. So just copy down the entire statement. Hence, we're going to have 1 plus 4 plus 7 plus dot 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 plus 3. So wherever we see n, we put a k minus 2. This is equal to, for the right part, we also substitute a k for n. Hence, we're going to have k multiplied by 3k minus, permit me to use a square bracket, minus 1 all over 2. So this is the right part and this is the left part. Let's go ahead and simplify this part. We have 1 plus 4 plus 7 plus dot 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 plus 3 multiplied by k will give us 3k minus 2. So this is the left part. And now for the right part, we're going to have this is equal to, let's work on the brackets first. 3 multiplied by k will give us a 3k minus 1 all over 2. Okay, so I can go ahead and still multiply this further. This would also give us k multiplied by 3k will give us 3k squared. K multiplied by negative 1 will give us negative k all over 2. Okay, so we have assumed true for n is equal to k, where we substituted a k for n. And this is what we have gotten. So right now, we're going to do for the third step. And for the third step, which is the inductive step, where we prove true for n is equal to k plus 1, it's a bit technical, but it's not really difficult to understand if you can watch me closely and pay attention to what I'm doing right now. So for step 3, so we're going to say prove true for n equals k plus 1. For this very step, first thing that you're going to do is to copy the assumption step. Copy down your assumption, bring it down. That's the very first step. Make sure that when you get to this part where you prove true for n equals k plus 1, make sure you copy down your assumption step and bring it down first. Hence, we're going to have 1 plus 4 plus 7 plus dot 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 plus 3k minus 2. Okay, so once you copy it down at this point, the next thing that you're going to do is to go back to the original mathematical statement for the left part. That's the first step. That's the second step. Go back to the original statement. Wherever you see n, you substitute a k plus 1. Listen to what I said because it's a bit technical at this point. I said that once you're done with your assumption step and you want to prove true, for n equals k plus 1, go to your assumption step, copy it down. After copying it down, you now go back to the original mathematical statement on the left part and replace the n with k plus 1 as you copy it down. Let me show you what I mean. So there is a plus here, remember? You bring down the plus sign, hence this becomes 3. Remember that we said that n is equal to k plus 1 in this case, hence it now becomes k plus 1 minus 2. Okay, now you can go ahead and also replace the right hand part of the original statement. Wherever you see n, you put a k plus 1. This will now become k plus 1 multiplied by, I'm going to use a square bracket again. Hence, we have a 3 over there. So wherever we see n, we put a k plus 1. K plus 1 minus 1. Okay. So do not forget the 2. This is all over 2. Okay. So remember the technicality here. I said once you get to your inductive step, which is the third step where you prove for n is equal to k plus 1, it is a bit technical. So you have to make sure that you work it out perfectly to avoid mistakes or wrong answers. So simply copy down your assumption step, bring it down. Now go to the original equation on the left part, copy the part that has an n down, then substitute k plus 1 for n. After doing the substitution, you now go to the right part, copy it down, and substitute k plus 1 for n. So that's how to do it. All right, so we can go ahead and simplify further. Now, the next thing that you're going to do is to compare this equation, right? You can compare this equation. If you look at this part, you can see that 1 plus 4 plus 7 plus dot 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 plus 3k plus 2 is equal to 3k squared minus k all over 2. So this part here, which is the assumption step, is equal to this. And we can also say that we have 1 plus 4 plus 7 plus dot 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 plus 3k minus 2, right? Is also found in step 3, which is where n is equal to k plus 1. So the next thing that we're going to do is to replace this part with 3k squared minus k over 2. Because this one here, this man, let me use this man here is equal to this very man. So we're going to eliminate this and replace it with what it is equal to. Hence, we are going to have 3k squared minus k all over 2. Now, remember that this part is equal to this, which we've just written here. So we're going to include the last term for the left-hand side. 3 multiplied by k gives us a 3k. 3 multiplied by 1 gives us a 3 minus 2. Okay, so this is equal to the right part where we have k plus 1 multiplies everything in the bracket. So we can now go ahead and simplify the bracket. We have 3 multiplied by k gives us a 3k. 3 multiplied by 1 gives us a 3. Okay, and now remember that this is included. We have a minus 1. All of this are divided by 2. All right, let's work on this part. We have 3k squared minus k all over 2 plus. So here we have 3k plus 3 minus 2 gives us a 1. And this is over 1, right? Because 3k plus 1 divided by 1 is still 3k plus 1. So it's now a fraction which we have to combine into a single fraction. So let's work on this part. For this part, we have k plus 1 multiplying 3k. 3 minus 1 gives us a 2. And all this divided by 2. So we can say that we're done with the right part because it's already in its factored form. If we expand it, we're going to get a quadratic equation, and we might have to factorize it again at the end. So our goal right now is to make sure that the left part is equal to the right part, because the right part is already how we want it to be, right? But this part here looks too complicated. So what we're going to do at this point is to combine these fractions to make them 1. So let's go ahead and work on that. To combine these fractions, we simply get the LCM of the denominators. To get the LCM of the denominators, we're simply going to draw a line here, and the LCM of 2 and 1 is simply 2. Okay, so 2 divided by 2 will give us a 1. Hence, we multiply the left part by 1. It's still going to remain as it is because anything multiplied by 1 will give you the same value. Hence, this becomes 3k squared minus k plus. For this part, 2 divided by 1 will give us a 2. Hence, we multiply the right part by 2. We're going to have 2 multiplied by everything here, 3k plus 1. Okay, alternatively, if you don't understand what I just did here, you can just multiply like you crisscross, where you multiply the denominator, the numerator and the denominator of the left part by the denominator of the right, and you multiply the numerator and denominator of the right part by the denominator of the left. You also get the same answer. Okay, so remember that this is the left hand side. So we can go ahead and multiply out. Here we have 3k squared minus k plus 2 multiplied by 3k will give us 6k. 2 multiplied by 1 will give us 2. All of this all over 2. All right, this is the right hand side. So I'm working it out like this because the board is not that large. Okay, remember that this part now, we have to factorize this because it's now a quadratic equation which can be factorized. However, let me go ahead to simplify further. So here we have 3k squared, negative k plus 6k will give us a plus 5k plus 2 all over 2. All right, let's go ahead and factor out this to see if we can get the exact answer that we got on the right hand side. If we did not get this after factoring, then there is a problem, so it means that there is a mistake. But if we are able to prove that the right part is equal to the left after factoring, then we have no issue. Okay, so what do we do at this point? We're going to use the AC method and then factor by grouping, because the A in this quadratic equation is greater than 1. Hence, what we're going to do at this point is to multiply the A and the C together. And now, if we multiply 3 times 2, 3 multiplied by 2 is equal to 6. Now, what two numbers are we going to multiply? That is 3 times 2. If we get a 6, so we're going to ask ourselves, can we get a 5 by adding them together? Yes. Hence, 3 plus 2 is equal to 5. So what we're going to do at this point is to split this middle term and replace 5 with 3 plus 2. Hence, we're going to have 3k squared plus 3k plus 2k plus 2. Okay, so let me go ahead and factor this, and I'm going to divide it afterwards. All right, let's go ahead and factor it by grouping. So simply group the first 2 terms and the last 2 terms. That's how to factor by grouping. So these 2 here are the first 2 terms, and these are the last 2 terms. Now let's ask ourselves what is common in the first term. 3 is common in the first term. K is also common. Hence, we can factor out a 3k. If we factor out a 3k from the first, we're going to be left with k. So from the second, 3k divided by 3k, we're left with a 1 plus. For the second part, we have 2 in common. So if we factor out a 2, what are we going to be left with? we're going to be left with 2k divided by 2 will give us a k. Then 2 divided by 2 will give us a 1. Please let me finish up here. Okay, so we can now go ahead and pick any one of this. Since they're both the same, we can pick one of this. Hence, our answer is now going to be k plus 1, and we pick the outer terms. So when you factor by grouping, you pick one inner term and one outer term. So this one is the inner term, which is in the bracket, and the outer term. And you know you get it correct, or you got it correct if the two inner terms are the same. If they are not the same, then there is a problem. This is when we're factoring by grouping. So if the two inner terms are the same, just pick one. But if they are not the same, then there is a problem. So you pick one of the terms in the bracket and the other outside the bracket. Hence, we're going to have 3k plus 2. Okay. All over. Remember, 2 divides them. Hence, we can now see that our left-hand side is equal to the right-hand side. Okay, we have k plus 1 multiplied by 3k plus 2 all over 2. And for here, we also have k plus 1 multiplied by 3k plus 2 all over 2. Next, we have to go ahead and conclude, because that's the last step. And how do we conclude? So conclusion, we say, therefore, by the principle of mathematical induction, the statement is true for all positive integers. So by the principle of mathematical induction, this statement is true. This is the original statement. 1 plus 4 plus 7 plus dot 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 plus 3n minus 2 is equal to this is true for all positive integers. And this is all we have for today. Thank you for watching, and see you in the next video, where we shall be solving more problems on mathematical induction. Thank you for watching.